Okay, so the homework was to implement the word jumble program from the end of chapter 3 in the book, which thankfully I gave you. So the word jumble program was pretty simple, but I want to go over the specifics of it first and then go over the answers. So whenever you ran this program, you were basically given a word that was scrambled, and then if you guessed it correctly, you won and the game stopped. If you guessed it incorrectly, it kept on asking you for a guess until you actually got it right. You could also ask for a hint, which gave you a brief description of what the word is. So if I just type in whatever, it would eventually fail. You would in the homework it was that you would lose points. I can also type the word hint, which tells me what the a useful hint to guess it, and if I actually guess the word, in this case it's jumble, the program exits. Cool. So let's go over the details of this because you can see that's it. You guessed it. Because this is using both arrays, nested arrays, as well as using random numbers to figure it out. So if we just go down line by line, I just kind of want to give you guys a brief overview of what's actually happening here. Let's just change this to be a dark theme. Okay. So starting off at the very top of the file, we have this thing called enumeration, and we've used enums before. It's just a way to assign values to things using names. These things represent numbers. Remember, enums assign a default number of 0 for the first one, 1 for the second, and so on and so forth. He's just using this to determine an easy way to reference whether the word that you're talking about is the word or the hint for that word. And then he specifies how many fields you have as the third enumeration. He has a constant integer to tell how many words you have in total. So we have 5 words. We have 5 words, and then we have, for each word that we have 2 things for that word. We have both the word and then the hint. So this right here is actually a multi-dimensional array. It has kind of like columns and rows, but instead of rows, this thing has 5 rows and 2 columns of information, right? So 5 sets of unknown words, and then 2 columns for each set, which is the word itself and then the hint associated with it. So that's what this is, rows and then columns, okay? That's how you can think about all these multidimensional arrays. And then he's initializing them inline, just like how he did the tic-tac-toe, okay? So this is an array of strings, and this thing has 5 times 2 elements. There's 10 total things in here, if you count all the actual words that he's inserting. Next thing we do is we seed the random number generator, and then we roll a random number modulo the number of words. So this will return you a number between 0 and 4, because this right here is 5. This is a random number that it doesn't matter what this number is. It's between 0 and some huge number, but this will always return you a number between 0 and 4. All right. Which he then uses that choice here to index into which row he wants. So remember, these are 0, 4. So this is 0, 1, 2, 3, 4. So these are the indices into each row. So that's what he's using here. Which row does he want? So in this case, he wants the row associated with this dice that he dropped, and then he has a variable that pulls out the word, and then a variable that pulls out the hint. So what is the value of word here? If you look up here, the value of this enumeration is actually 0. So we can just replace that here, just to show you guys what that actually is. And what is the value here for hint? It's 1. So if I rolled a 3 for this choice, which of these words here would it be? So if I rolled a 3, what is going to go into this variable right here? So row 3, column 0. Row 3. Remember, the rows go from 0, 1, 2, 3. Right? So persistent is going here. So this is actually going to be persistent, right? And then this one is row 3, column 1. Going to be keep at it. So that's ultimately what this program resolves into, right? These 2 words. That's what it's storing into these variables here. So then he's taking this word and he's assigning it to another variable. He's essentially doing this, right? He's plugging it into here. And then he's getting the length of this. What is length equal to in this case? How many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So he's assigning length equal to this variable dot size. So this returns 10. So that gives you that 10. Okay. And then he's running a loop that uses that variable. So I'm just going to keep replacing these things. So this is a loop that's going to go 10 times, right? And he picks 2 random numbers between 0 and 9 in this case. And then look what he's doing here. He's swapping those 2. Okay. So if he pulls, let's say this thing turns out to be, I don't know, 3, and this one turns out to be 5. What is jumble at 3? Remember, this is 0, 1, 2, 3, right? So this character S. So he substitutes that S. He pulls this guy right out. And then jumble at 3 is equal to jumble at 5. What is jumble at 5 equal to? 3, 4, 5. Okay. This is actually 5. Same thing with this. This is actually a bad example. I'm going to change this to be 4. So jumble at 3 becomes whatever 0, 1, 2, 3, 4. This becomes I. So he's basically swapping these 2. So he's taking this and putting it over here. So because he's using numbers to basically swap 2 characters in this string. And he does it 10 times just because it's not, he could probably do it 100 times and it would jumble up just as much. But he's doing it 10 times to go over every letter. Afterwards, he prints out some instructions, asks for a guess. Then here's the expression for the loop. So he wants to keep repeating this loop until the player has finished guessing, or you type in the word quit. So if you type in the word quit, this evaluates to what? What is this? Is this true or false here? Does anyone know? What is this, true or false? It's true. So what's the opposite of that? False, right? So this is false. Okay. If I have anything ended with false, this whole thing is false, which means it doesn't matter what this is here. This could be false. This could be true. Even if this is true or false, in either case, this whole thing is going to be false, which means in that case, this whole thing exits. So that's how that quit works. If you type in the word quit here, it'll actually not go into this loop and you'll exit the program. Okay? And the word itself is, in this case, persistent. So as long as the guess is not equal to persistent, then you're going to keep looping. If you do put the word hint in there, it's going to output the actual hint that's chosen for that. And that's it. So ultimately, it goes down here. At the final piece, it says if the guess is equal to the word printed out. This is in case you quit the program early. You type in the word quit, so you don't want to print that out. All right. So now I've gone over how this program works. So let's add a scoring system. So the homework was to take this program and give you score based on how long the word is. And you would lose points for every time you failed to guess the word properly. So we should use the length of the word to figure out the score. And thankfully, the length of the word is right here. We've already calculated the length of the word calling size here. So if I just create a variable here called score, and I make it equal to like length times 100, now this will be 400 points if I guess that word correctly. And this will be 700 points for guessing that one correctly. And then what I'll do is I need to figure out where's the best place to subtract score from it. I basically want to subtract score every time they guess incorrectly, right? So here inside this loop, you only go inside this loop every time you guess incorrectly, or if you type the word hint. If I give a hint, I can subtract 50 points. If I guess incorrectly, I could just subtract 100 points from here. And that's it. So we only have to put that behavior in here. The loop will automatically take care of subtracting 100 points every time we guess incorrectly. And then either way, if you guess the word correctly, I can say, hey, you got a score of. All right. So now it was basically like 3 lines of code you had to write, plus a C out at the end. You initialize the score equal to length, and I did it by 100. I went down here and I subtracted points where I needed to, and then I printed out at the end. Now when I guess, I'll screw up 3, 4 times, and then guess the word. So that word is 4, 8, 10. So it should have been 1,000 points, but I guessed wrong incorrectly 4 times, and I got a score of 600. Okay, pretty simple stuff. What else could we do with this program to make it more kind of interesting? Or is there anything else that people thought we could do to make the word jumble interesting? So one of the things I thought would be cool would be load in a dictionary. So you're getting always different words every time, and print out the description of those. That'd be kind of cool. Because 5 words, I mean, you kind of figure out what those words are pretty quickly. What are some other ways that we can make this game more interesting?
Maybe more points. Maybe.
More points? Does more points make it more interesting? Like, you mean like if I did that?
Not like a legitimate amount of points, like you get for
What if you
like each word and stuff.
What if you gave like certain letters if they got it correctly?
Oh, I see. So if you actually guess part of the word correctly?
Yeah.
Yeah. Although, I
But
wonder
you
if...
can't, like not in the same exact spot. There are.
Like, this game sucks no matter what. Like, I understand this game is not really an exciting game.
The game can be exciting.
What'd you say?
What if you take out letters?
Take out letter. Oh, interesting. So you actually show only part of the word, right?
Yeah.
Gaps of the word. That'd be cool. We could do that. I think it'd be cool to also. What are the problem is, like, yeah, you want it to be more like a hangman style game where you're like guessing individual letters and it tells you as you're getting those letters correctly, as opposed to having to guess the whole thing. It'd be nice if, as you put in guesses, it would tell you how many of those letters you actually got correctly. I'm wondering what the thing is about this game that makes it not interesting. And I think for me, I think it'd be cool to have a combo system in a way. Like, imagine you had 1,000 different words, and you're presented with a word, and every time you guess it correctly, the more words you guess in sequence, the higher combo is, the more score you get. So you want to take your time and actually figure out what the word possibly is. Because right now, there's not really a big penalty. You don't really lose anything for just guessing. And, like, the score doesn't mean anything anymore, right? So I think having a combo system would be pretty cool to do.
The one thing I wanted to figure out is like when, like, say you kept guessing the word wrong, so I had that, and when it gets to 0, tried to put something in the if statement to have it go stop it from going below.
Oh, sure.
And I couldn't figure out how to get it to stop going below.
Oh, I see. Did you want them to keep guessing?
Yeah,
I guess,
like, I
okay.
couldn't figure it out, you know, like.
So here, yeah, if you ever wanted to not go below 0, that's actually really easy.
Yeah.
Right after here, if score is less than 0, just set score equal to 0.
Yeah, and
It requires your brain to think a little bit differently,
Yeah.
actually. This is a very common thing to do in games. We typically don't want health to go below 0, and if we typically don't want damage to go below 0, so we do this. We have in Overwatch, we have a tmath max function, and max returns you the bigger number out of 2 of those things. So what would this return in this case out of these 2 numbers? 100, right? Because it's a bigger number. What would it return out of these 2 numbers here? So what we typically do is when we have score, we would set score equals tmath max 0 and score. We do this for like health. We have this exact line of code for health when you subtract it. This means give me the max of either 0 or health. So in case health goes negative, you'll only be at 0, right? Health can still be like a billion or a million or trillion, but then that will be correct here. But if health, as soon as health goes to like -1, health will be set to 0 instead. So that's what you kind of want to do. That's what this if statement, that's ultimately what this thing does. This is what the math, that's 4 lines of this is reduced to 1 here. This is the same as doing this, and that's basically what this is. And this is a function, which we're going to learn today, thankfully. All right, let's move on a little bit. So before we dive into functions, there are a few things I want us to review. I always want us to kind of make sure that we remember the fundamentals. I know we sometimes go kind of fast in learning things, I don't want us to lose sight of the things that make programming kind of interesting. So I have a few exercises I want to share with you guys that I thought would be fun to do together. So I have a few labs here that are review of loops, as well as some review of a simple combat simulator. And I kind of want to spend some time doing the first two labs, and then I'll give you guys the third lab if we have time. So I'm going to put this up on Zool. I'll put lab number 1 and 2 and the documents up on Zool in the SDVA103 folder. Let's just go over lab number 1 together. I mean, I'm going to have you guys do it. This is a very simple program. The program, literally all it does is prints out 5 stars in a row. Okay? This should be really fast. So what I want you guys to do, I want you to grab lab number 1, and I want you to do the 3 assignments right now in your Visual Studio. So that I want you to change the program so that outputs 10 stars instead of 5. Change the program so that there's a space between each star, and change the program so there's a tab between each star. And so the way you put a tab is either insert a tab or you can do /T. Okay. Once you're done with lab number 1, which should be rather quickly, it's just like a super fast warm-up, is jump into lab number 2, which is a nested loop. And lab number 2 is basically very similar. Lab number 2 just prints out a square of stars. Okay, and then lab number 3, don't start, well, you can start lab number 3 if you want to, but we're going to go over it together before you jump into